Is a mic good for the camera? All good? All right, we'll let everybody kind of trickle in, but we'll go ahead and get started just for the sake of time in the next session. I know I can see already everybody's face is really excited to get into engineering ethics, so we'll try to make our presentation a little bit quicker. So my name is Miguel Rivera. I'm the application engineer for EnergyTransition. We'll get into a little bit what that means, but a little bit about my background. So I've been with Eaton for less than a year. I serve the Gulf and the 4 states surrounding Texas. So that would be considered the Gulf region. My experience is that I've been involved with renewable, sustainable projects for more than 10 years now. When I first started my career, I started at Environmental Chemical Corporation. They were a contractor. They were one of the first ESCO companies that went around the United States, did energy audits, energy analysis on basis, and then you brought your proposal to the table in terms of what energy conservation measures and what renewables and what you can install to kind of get that payback. The reason why that's important is just to kind of give you context is we had all the skin in the game. You financed the projects, you were the one that did all the construction, managed everything, and the end user, which is typically the basis, would then give you a percentage of the savings over a monthly period, and that's how you paid back the projects. So there was one, I share that story because there was one kind of turning point where every single project was a win, and every single project got your money back immediately. Paybacks were less than 5 years, and everybody was shaking hands and celebrating, and that was when LEDs came around. So I don't know if you guys have been around that long or have worked on projects when that first transition. Now it's common knowledge. Now, if your facilities manager is not recommending LEDs or you haven't retrofitted, they should fire that guy immediately. But there was a point in time where each fixture was expensive. I mean, it was about $80, $90 a fixture. Now you compare it to a 60-watt light bulb, they're pretty comparable in price. So the energy offset was already there. There was also a point in time where you had people that didn't like the color temperature. So, it was either too blue, too green, we're not gonna do LEDs, get them out of here, even though the payback and the savings were there. So again, my background, been involved in those type of projects and traditional MEP electrical design projects. I've been kind of boots on the ground like you guys, service calculations, putting receptacles everywhere, forgetting receptacles, forgetting to put lights in different places. I mean, I've done that as well. But the reason why I bring that up is because LEDs and were, yes, part of energy conservation because you got that energy savings, but really they were more of a market disruptor. So the reason why we're really talking about EVs and EV infrastructure is EVs are a market disruptor. They're not really, yes, they're tied to renewable energy, sustainable energy, only because it makes sense in terms of taking advantage of the capacities that are out there, but really it's a market disruptor. It's a technological advancement compared to, IC or internal combustion engine cars. So that's a little bit about my background. I'll go ahead and, you want to introduce yourself, John?
Yeah, so my name is John Gacchia. I'm with Eaton's North American sales team. I'm director for EnergyTransition. So I've been building a team of application engineers like Miguel. Miguel, like you said, is our application engineer for these kind of projects in the Gulf region. But if your firm has offices in other parts of the country, we have other application engineers around the country that can help, and Miguel can help you connect your other offices with those. We'll kind of tag team the presentation here. Miguel's going to do most of it, and I'll chime in with some color commentary now and then on some of the projects we've been working on to share with you what we're doing in the energy transition space. We'll open it up at some point to kind of hear what you guys are working on as well too.
Yeah, so in terms of, the reason why Kevin said that we wanted to make this a little bit more interactive is because, we're just launching our chargers. There's other people in the space. And really, I could go down the spec sheets, but, there's a breaker and there's Wi-Fi on that breaker. I mean, that's about as complex as it gets. Everybody is, has a background in electrical. We're just kind of talking to you guys out there while we're in our booth. So, there's not much you're going to learn in terms of looking at the charger itself. So, so right now, let's just take a quick poll real quick on who drives an EV now. So actually, it's interesting. Actually, statistically, that's about right. I mean, if you kind of look at it right now, the adoption rate in the United States is only about 2%. So there's a couple of drivers that are going to change that. and we'll kind of get into that. What are you guys seeing right now in terms of your designs or EVs, or when you're talking to developers, landowners, landlords? What are you guys seeing now? Yeah, so that's a good one too. So what is the request, or what is the local jurisdiction asking for? So what type of occupancy is it? Industrial. Oh, that's more of. So in terms of regulating that or mandating it, how many parking space? Let's say a percentage of parking space. Are they mandated based on percentages, or? So what's a percentage? Give or take. 1% of parking spaces. Well, I thought you were going to say a lot more than that. That doesn't prove my case at all. So is anyone else seeing anything like that where the local jurisdictions are either asking for it or? So let me ask you this: on multifamily, if you guys work in, besides commercial industrial, if you work on multifamily, is that a request that you're starting to see as well, in terms of at least building in, a junction box or sizing capacity, maybe adding a separate service for electric vehicle chargers? How much? 2 to 5%. Yes, in terms of percent, or just starting to see it? Most require around what? 2 to 5%. Okay. Have you guys have any of you guys done a service calculation or load analysis, including EV chargers at all? Yep. So on percentage, how much does that increase your base load? So let's take a level 3 is a little bit different. You're not going to see those kind of in typical applications. That's going to be dedicated to wherever spot you're in. But let's say a level 2. 40%? Yeah, there you go. That's a bigger number. That's more of what we're trying to aim for. So, and someone else mentioned also that you guys did a service calc with EV chargers as well. Yeah. What was the percentage increase in your base load? You don't remember? So 50%, right? You want to top his guy's numbers. All right. So, kind of the point of that is. To kind of get a feel of what you guys are seeing. I know that, maybe because we're specifically in this realm, but, a lot of contractors, designers are coming up to us. We have a different fleet of products. We have in different kilowatt ranges, but that's more or less of what we're seeing as well. So, 40 to 50% increase in load. So if you that's kind of at a micro level, but that's a new construction. It's easier to accommodate that. It's easier to kind of, make provisions for either transformers, extra load centers, but what about retrofits? What if retrofits? What if you have a facility where you have to retrofit some of that infrastructure to be able to accommodate this extra load? How easy? You start thinking about how easy is that going to be? So if you take two things away kind of from this presentation, is one of them is, if you don't know anybody that drives an EV, and maybe actually that's a good one. Since you drive an EV, what's your experience in terms of charging your vehicle? How do you charge your vehicle? In your home? No, that's a good response. Do you ever go out in public and seek a charger? Like, do you go, okay, I need to go refuel my vehicle, so I'm going to go over there? You haven't needed to yet, right? So right now, that's the kind of statistics that we're seeing with most people that own EVs. So 80% of them will charge them at home. That's why, based on default, in terms of home load calculations, multifamily, you're going to need a charger wherever you go. And actually, her second response is the same thing that we see with all EV chargers as well. So that's the shift in the mindset. So from an electrical perspective, we can take advantage of that because now we upside the service, we make provisions, we size, set up junction boxes, set up the transformer. We can plan for that extra infrastructure. But, the shift in mindset and the kind of pushback or the things that you get from people right now that, because everybody's used to it, is you're not going somewhere to refuel your vehicle. You're refueling your vehicle wherever you are. It's more like charging a phone. And when you kind of think about that a little bit and kind of replay it, then it kind of makes sense. And then you start thinking, okay, well, that means that there's going to be electrical vehicle chargers everywhere. Why? Because like right now, for example, if you look at even a traditional model of a gas station, right? How do most gas stations make most of their money? They don't make money off of the gas that they're selling. They make it for the foot traffic. So you're going in there, you're purchasing gas, and they're making money. I mean, look at Buc-ee's, right? I mean, people spend hours there at Buc-ee's just for all the brisket sandwiches that they're selling, and they're one of the most profitable restaurants, considered restaurants in Texas. So they're making money off their food. So it's going to be the same thing in shift in mentality in terms of charging vehicles. Now, if you're a business owner, if you have, a movie theater, bowling alley, well, now it makes sense, in order to drive customers, that foot traffic, that those chargers are going to be there. So in order to kind of accommodate that, because you probably have also heard, all the stories, studies, and everything in terms of doom and gloom, upgrading 40%, if you just did that linearly, for you guys, I'll ask you guys in your service territory, the utilities that you worked with, just give me, I'll call on somebody. What's the last utility you worked with? Encore. So if you went anywhere and said, I need to upgrade the service, 40%, or you need to upgrade your whole infrastructure by 40%, what are they going to do? They're going to say, too bad, you can't install these chargers. I mean, you just wouldn't be able to do it. The good thing that there's kind of other drivers that are going to push that as well. So, I'll briefly go over some of our solutions in terms of load management. We have our smart breakers. I'll go over, since you guys are begging me, over our car charger kind of specs. We'll go over our energy storage solution, and then I'll go over our kind of a case study of a microgrid that we have installed in Puerto Rico. So our approach and the way to kind of solve this issue, utilities right now, even if they think that they don't have an issue, asking them to upgrade to 40% to be able to accommodate the extra infrastructure for electrical vehicles, it's not possible. So the way our mindset, you're going to see the slogan on everything that we offer. It's on our brochure, it's on our website, is that we're changing our mindset to thinking of everything as a grid. So that's the loads, that's your sources. Everything now is going to be two-way communication. So traditionally, and I would say even, when I started, about 10 years ago, this line has always been linear. You have your generation stations, scattered throughout Texas, nuclear, natural gas, coal, all those plants. And then that goes through your transmission systems, that's down to distribution, then you feed your loads. But what it means, everything as a grid, kind of even from a macro level perspective is, even your loads now can be considered microgrids. They have their own distributed DERs. They have their own storage solutions. They have their own EVs. So we'll go over this product as well too. But another reason why an EV can also be considered a market disruptor, and it's coming closer than you think, is actually EVs now can also be not just a load but also a source. So it's not just kind of power flows, because that's the way that we'll think of it as electrical guys. That's power flows, everything's going two ways. All your infrastructure has to be beefed up to be able to handle, both sources of current. Your short circuit calculations change, your load analysis change, the shifting peaks change. So it's all that power flow makes a difference in terms of the grid. But it's also going to have to be, the reason why we consider everything as a grid now, it also has to be communication as well. So I'll use Texas since everybody's from here, but let's say the entity that kind of regulates transmission here. Is anybody familiar with the entity here? They got in trouble 2 years ago? ERCOT, yeah. So ERCOT is more of your traffic controller, right? They regulate your transmission. They're the ones that are viewing from a macro level, anything that anything that's a renewable that's over 1 megawatt has to be registered in ERCOT, so they have visibility in that. They're also deploying and also sponsor grid storage to help have energy storage and call upon it whenever needed to help that get connected into the transmission systems. And then your distribution and on is going to be more of kind of your local utilities. So the funny thing is that the communication infrastructure between everybody is already there. So in my times, I also spent some time working for a utility, and the communication in terms of reporting, some of it is a little bit antiquated, but now it has to be more of gathering real-time data. So right now, what we would do is if you had a solar installation kind of on the load side, you would send a quarterly report to ERCOT, anything that was registered over 50 kW. But that's it. It's a stationary report. You don't have anything. You just tell them, okay, and we have this many meters. This is how many solar installs we have that are over 50 kW. And then they keep it, and then they store it. And hopefully they put in their data analytics, but since it's not data that they're processing, it's more of kind of record bookkeeping, right? So, and the last conversations, even speaking with ERCOT, they were having an issue with, I don't know if you've heard of the term phantom load. Has anybody heard that term? So what is a phantom load? Oh, no, you're good. No, like I said, I want to make it interactive. Nobody else wants to participate. But so what a phantom load was, basically they have all these DERs that are not registered because anything under 50 kW. But what would happen is that once on a cloudy day or cloudy areas, well, guess what happens? The solar drops, the solar's gone. So now you have, ERCOT was saying, well, we have projected load that's going to be this much, but now all of a sudden on a cloudy day it's this much. Well, how do we get that delta? How do we really account for it? So in terms of the communication schemes being there, also if you guys are familiar with what happened 2 years ago, basically the communication is there. So here in Texas, we have something called 4CP. Are you guys familiar with 4CP? So basically we peak in the winter and we peak in the summer. So in the winter, that's not going to help you out with the solar. So that's an issue in terms of calling and having that available resource as generation. But let's just take the summer for example. So 4CP means that they take 4 readings of your peak load during that season, and they'll send an alert out to the utility. So, like my utility, I'm from San Antonio, CPS gets those alerts, and then they pass it on. That's where, all the demand response programs come, where they want to control your thermostats or any loads behind the meter. That's where they get the alerts from ERCOT saying, hey, we think we're going to peak based on temperature, based on the climate that we're in, based on how hot it's going to get. They'll send them an alert. So then now CPS responds, and they do that, again, they do that in the winter and they do that in the summer. And what happens is once you register that peak load, your utility then is responsible to pay ERCOT the fees based on a percentage of how much you contributed to that load. So the point of that is that the communication systems are there, but now it's about giving them real-time information and making that more of a dynamic play. The funnier story, did you guys hear what happened in California last year? So when they mandated the 30 by 30, so 30% of vehicles have to be EVs by 2030, and then subsequently then they mandated that by, I think it's 2050, that you can't sell any IC vehicles. Well, guess what happened a week later? Does anyone remember that story? They told everybody to stop charging. So the issue with that is like, it became a meme. That's an instant meme, right? That's a self-owned. That's pretty bad, But the thing is that was same thing. So they have the California ISO. That was the ISO saying, hey, we're peaking, stop charging. But from a utility perspective, regional, where you're controlling all the meters behind, your service territory, some of them were saying, hey, we're not peaking. We can still take some of the load. So again, it's funny, but at the same time, the systems are there. Now it's about molding them in terms of correctly charging vehicles. Does anyone have any questions or stories about EVs or no? All right, so I'll give you a couple facts and statistics so that way you can walk away and say, okay, well, I know that, and I know that's going to be an issue because of that, and this guy told me. So Stanford actually released a study last year. They created a model in terms of EV adoption and how that was going to impact the grid. So there's 2 points to kind of take away from that, is that once we hit adoption rates of 30 to 40%, that we're going to require 25% more capacity. So it's not necessarily the 40, but even 25%. If you put that into perspective in terms of the utility, are they able to really deploy quickly, especially with lead times, pricing, everything? Are they going to be able to increase their capacity by 25%? The answer is, I'll give someone an easy one. The answer is, cut you off guard. The answer is no, right? So no, that's a huge undertaking. And then once we hit adoptions to 50%, without having communications, without doing anything, you're going to shift the peaks to nighttime. So again, just to put it in perspective in kind of a micro level, so the charger that we have out there is 7 kW. 7 kW is equal to how much tonnage of cooling would you say? 3. Yeah, 3. So 3 tons of cooling is about what the load that you're going to be adding to every resident. So again, just thinking of it as a linear, that's going to be really difficult to manage. Especially that now that you pay attention to the designs, so you do a service calculation, you ask for this many amps, you do this, this size transformer, and then what does the utility do when they send out a transformer? Oh, they cut it in half, because now you have LEDs and everything's energy efficient, so you're not going to have ample capacity to be able to manage that load. The other one, just a quick analysis, Reuters did a study, this also was published last year, that 70% of transformers that we depend on, 70% of transmission lines are over 25 years, and 90% of transformers are over 40 years old. So, a question came up, why aren't transformers smart? It's like, well, that was 40 years ago. We didn't have communications, we didn't have all the metrics, gauges, pressure, oil, all that, in terms of being able to collect that metric or send that data somewhere to be able to keep up with the life of those transformers. I mean, that was a long time ago. And then I took a kind of quote from the Texas PUC, the Public Utility Commission, and they released a report. It was in 2020, but they did an analysis on the Texas grid and how it's going to handle EV chargers. How do you think that they did? I mean, I kind of have the answer up there, but in terms of level 2 residential, they said most of the utilities, CPS, Austin Energy, all the major ones, Encore, CenterPoint, they all said we can handle it, we're going to manage it, it's not going to be a big deal. But what they were afraid of was actually DC fast charging, and I'll explain kind of the difference between those, that we don't have sufficient capacity for something like, or infrastructure to be able to tie in, that many DC fast chargers in one location. The report, you kind of have to skip, I don't know, it's 100 pages, something like that. You kind of have to skip to about page 70. Guess what the first 70 pages are about? How are we going to pay for the roads if nobody's paying for gas? All right, so Department of Energy released the statistics, and this is what we're basing on, kind of our projections and everything on, is we're going to require to meet the demand of EVs as the adoption rates go up, and we'll go into a couple reasons of why the adoption rate is going to go up. We're going to need 75 million chargers to keep up with the demand. The point of that is, again, as we mentioned, that it's, if you kind of shift your perspective in terms of you're not going somewhere to charge your vehicle, you're charging your vehicle wherever you're at, then what that means is that electric vehicle chargers are going to be everywhere. Multifamily, especially, you don't have a garage, they're just going to be it's going to be a commodity. They're not expensive. It's small, but it's going to be like an amenity that anybody offers to get foot traffic in there. But they're just going to be, the way that we envision it. And if you kind of see the trends in China or in Europe, you just have them in parking lots. It's more than 5%, but probably closer to about 30 to 40% of the parking lots taken up by chargers. So, in terms of the adoption rate, what's going to happen is that EVs are going to be adopted more and more. I'm surprised that 1% follows the national trend, but a lot of guys, you guys are electrical. This is how we make our money. But federal and state kind of legislation is going to push that drive. So right now with the Inflation Reduction Act, you get $7,500 tax credit for buying a new EV. A lot of states are adopting legislation where, if not, with the normal consumer, but 30% of vehicles have to be EV by 2030. If they're not passing that on to consumers, it could be like Texas. So we don't have a 30 by 30. We're not following that, but we are following in terms of trying to get up the percentage of the state vehicles. So any fleet that belongs to the state, getting that up to electrical as well. So, those are kind of mandates that's going to kind of push that. And then you also have local incentives. You mentioned AHJs that are starting to enforce having a certain percentage at certain parking lots. And then you have utilities, which, rebates. I know, again, going to, I'll use these as examples, but CPS offers a rebate where they give you money to install your charger. And then after that, they give you a monthly rebate as well. It's not much, but it's refueling. It's one refueling of your vehicle, which is about $5, a month. But what they're asking for is communication and on-site visibility to that charger, it being able to send you alerts and being able to give you an optimized schedule in terms of where you charge it. So there's some utilities that are starting to adopt that because they recognize everybody plugging in at the same time is going to be an issue. But if you manage that correctly, then we shouldn't see any issues. As I said, business incentives, bringing in that traffic. And then again, just the technological advancement. If you've seen videos on how fast EVs go, the room, the space, everything within a vehicle, it's just overall, then autonomous driving will kick in. Overall, it's just a better technology. This graph, I know you guys can't see it, but if you kind of look at the solid blue dots, just wanted to show that to you. So the other kind of incentive, this is more for DC level 3 fast charging. This is what TxDOT, this is their five-year plan in terms of how they're going to install DC fast chargers based on adoption rate and where they're going to sprinkle them out throughout the state. So, right now, if it looks like it's scattered, but really if you kind of follow one solid line, it kind of follows like a major highway. So that's, if you've heard the term NEVI, that's the NEVI funding, all the Department of Transportation, that's distributed by state. But in TxDOT, here in Texas, we get a little bit more money than most of the other states. So we have $85 million to spend this year on DC fast chargers. You have anything to chime in, or do you have some?
The programs, National Electric Vehicle Infrastructure Program, like Gail mentioned, so federal government and maybe state money along major highway routes because of its size and per mile. Big chunk of that money that's coming into the federal government that's going to be deployed over the next 5 years. So you are going to see a lot more DC charging infrastructure. So you won't always have to charge at home. You'll drive at Houston if you want. San Antonio, stop along the way, find a charger much more convenient going forward. And that's all going to happen over the next 5 years because that federal money has flowed to the states, and the states are now starting to deploy it here in 2023 for the next 5 years.
All right, so the next two slides are just to kind of show kind of a micro level. There is a difference between kind of commercial, industrial, and residential. Residential most likely is going to be 1 or 2, electric vehicle chargers. Again, you're going to have some sort of load management or control, have visibility to it, because again, if utilities catch up, what's going to happen if they don't have ample capacity? What they're going to start doing is changing regulation, changing tariffs, and mandating certain things in order for them not to have to pay or upgrade their infrastructure. I mean, it's just, just speaking to the utilities and being kind of on that side, that's what's going to happen. I mean, utilities never lose. If you guys have ever played with utilities, they never lose. So they'll find a way to kind of force that. So, but in order to be ready for that, EV chargers is important to have that communication and have that control. And then, some of the things that, and we'll get into the specifics, but now, other load management tools. So if you've done a service calculation, if you look at, I think most homes, the average age home in the United States is about 40 years old as well. And you guys can fact check me, it's recorded. So, are you going to be able to upgrade that service to have one or two chargers at that service, right? Most likely they won't have ample capacity where you can just pop in a breaker and charge and plug in the charger. So what you'll have to have is some sort of load management. So now, you can consider them non-coincidental peaks, right? So you get non-coincidental loads. Instead of turning on your range or your heat pump or your cooling, now you charge your vehicle at that time. So, being able to make that device a smart device is a huge benefit, and that'll help kind of with these upcoming issues, right? Or anticipated issues. A load center, we're working on products in terms of making that smart as well. And then we have our own software as well to support that. From a commercial standpoint, it's a little bit different only because, solar panels, generator, large energy storage, those are all things that you can take advantage of to become kind of that source or to become, to play into the market as well. So is everybody familiar with HEB stores? Yeah, so it's really large. If not, it's coming here soon for sure. But, if you go down south, HEB is kind of the prominent grocery store. So if you ever get a chance, one of the things that they set up is they have a microgrid partnership with a company called Enchanted Rock. You guys are familiar with that? Have you heard of that? So Enchanted, that's actually a really good partnership. They win awards every year just because they're able to respond to emergencies. So basically, that's the way that I envision, kind of commercial space in terms of making that mutual kind of partnership and help solidify the grid. So basically what they did is they went in there, they went to every HEB and said, hey, you have a large enough load, you have enough space, I'm gonna install this natural gas generator, I'm gonna operate it. All I'm gonna do is, if ERCOT ever calls on emergency, as an emergency response system, if they ever call on it, then I get to turn on my generator, and HEB said, okay, well, I can island, if the power goes out, I have it. Well, it's a win-win for everybody. So HEB never loses power, and Enchanted Rock's able to sell back to ERCOT, so they're registered under ERCOT. So after the first kind of freeze, they made their whole capital investment up in that first freeze. So just to give you an example, I was just keeping up with rates. Typically wholesale rates about 2 cents a kilowatt hour. During that freeze, it went up to almost $600 a kilowatt hour. So, do the math in terms of how much energy you're producing, and, that's where you kind of make your base cases. But that's the way I envision, and the way that we're kind of thinking of things being able to communicate is just having that energy storage, and then, of course, industrial, commercial, have a lot more landscape to be able to install, larger solar installations as well to be able to offset energy and peak. So all right, so again, we have our smart breakers. We have our smart breakers that we offer. Again, this is load side management. This, you pop in BR, BAB. This makes any device smart. So I'll just quickly go over it. A big example for residential. I don't know if you guys work in the residential realm, but in terms of making a real quick, easy one in terms of making your water heater smart, that's a huge advantage, right? Because you know your schedule. Everybody, if you start looking at load profiles, everybody has a schedule. Everything is cyclical, so you know when to turn on your water heater and when that hot water is going to be available. And I promise my wife agrees with that as well. Actually, no, she gets mad all the time. And we have our software in terms of being able to program. You can schedule it, turn it on, off, check data analytics. So it's another form of energy metering within that branch circuit. One of the things that we don't publicize, but another thing that we're trying to push for is, actually making that your back feed breaker if you do a load side connection for a solar as well. So now you don't have that separate device or metering device that's measuring the solar. You actually just have it in the panel. All right, so just quickly in terms of infrastructure, because I know that was a title, so you guys get, at least you take some technical kind of knowledge from this presentation. But basically, again, this is the way that we kind of envision the way that, commercial, large industrial spaces or spaces that require a lot of chargers. Now, you're going to have a separate switchboard, most likely at 480, just to handle the DC fast chargers. And then you'll have, so it'll be a switchboard above your inline, and then downstream would then be what you would call your main distribution panel that actually feeds your loads. It's going to be the only way to kind of accommodate everything, installing solar panels, energy storage, and the meter. So what that means is now we sell larger bus, familiar with codes like 705.11 or 705.12 in terms of interconnecting and making everything work together, and the power flows being in sync, then everything has to be sized appropriately. Our level 2, that's more of our 240, 208 application. So, step down transformer. So the point of this slide is just that, just when you're factoring in kind of that load analysis, looking at how you're going to design this, it's going to be a lot more robust design than just having a panel and then your branch circuits off that main distribution panel.
Are not only deploying EV chargers, but like Miguel showed on here, we're also trying to figure out how to sustainability, or part of a university campus that's adding a lot of solar PV. So how do I add that into my power system? Like they're thinking about battery storage, so they could store solar that's generated in the day and use it later during the day. Peak load occurs later in the day. That's always not synced up. And they already have a generator and they have a utility. So how do those all work together? So having a switchboard structure that can connect all those at typically the 480 volt level, like Miguel showed there, and then there's a control layer platform that can coordinate all that as well too, as to which of those distributed energy resource operates when and how to operate that. So there's a power distribution side and there's a control logic side as well too. And then you're just powering your DC or AC chargers off of that same infrastructure because they're another load now in the business.
Yeah, so, since we kind of got the cue to kind of wrap up, we have the spec sheets online in terms of our energy storage. We offer a 400 kW solution. We've kind of committed that because in terms of DC level fast charging, those each of the chargers are 150 kW. Pairing those with energy storage makes you, not hit those peaks, especially as I was mentioning, you have the 4CP kind of peak seasons. We don't have, that's something that we're working on in terms of modeling and being able to offer a simulation in terms of what that looks like, in terms of what the load profile looks like, but that's all going to be, vary by location and adoption rates. So does anyone have any questions? Or?
I also add that, just like talking about this both on the power and infrastructure side and the control side, in Houston we have what we call one of our power system experience centers. We have 2 in the U.S. right now, one in Pittsburgh, where I'm located, and the other one is in Houston. So we have all our power distribution equipment, switchboards, and many transformers there. And if you felt you've been there, if you haven't, talk to the local team here that you can visit. But we're also implementing all our EV chargers as well as microgrid demonstration with solar, battery storage, generator, and have it all work together with a microgrid control system. So be happy to arrange a visit for you there so you can see some in action. Because if your clients aren't asking for it today, they probably will be more and more. We're starting to see, especially some of these microgrid projects, moving from what used to be military-based applications to now more the commercial and industrial space. As Miguel mentioned, we're implementing 2 microgrids at 2 of our own factories in Puerto Rico, manufacturing plants where we make circuit breakers. And we want to make sure those are reliable. They had some issues with the hurricanes down there, so we're putting that in from a resiliency standpoint to make sure those plants can keep running during the next hurricane, but also to offset CO2 emissions because Puerto Rico generates a lot of electricity from burning oil still. So Eaton has our own sustainability goals, but so do many other corporations and universities and hospitals. And so the whole, there's lots of push to reduce CO2 emissions. And adding solar is a good way to do that, and integrating it with a microgrid control system is a great way to do that. So, happy to arrange a visit for you at the Houston site to show you that. Any questions, comments from anybody in the group?
Question on the contacts, and then we can add either PLS system or battery if you want to restrict usage.
Yeah, so that one is our residential application, so you won't see it on that, but we do have our other commercial applications have RFID reader to scan, so give you access, and QR code. So if, same thing as you go downtown and you scan a parking spot and then you pay, it would be the same thing where you have access to that charger as well. All right, thank you guys.